Okay, here we are at 4.4, and as promised in our pursuit of linear equations and inequalities in two variables, our goal of becoming an expert grapher of linear equations, we are now going to take what we know about intercepts and slope and use them with that friendly form of the equation, y equals mx plus b, the point slope form, I'm sorry, not point slope, the slope intercept form of the equation of the line. So let's keep our goal in mind, and that is to become experts in graphing linear equations. And we want to be able to do that from the equation to the graph, creating the line on the graph, and we also want to be able to do that in reverse. An expert can do things forwards and backwards, so from all angles. So we also want to be able to go from the graph directly to the equation, and anywhere in between. If we just have some knowledge about the line, how do we get to the graph, how do we get to the equation, all those aspects of it. So let's review a little bit what we know so far, and we'll use these four equations here to demonstrate some of the things that we know. And there's a point to this review, so don't just skip over it. We're actually going to use this to get a little bit better at what we know about slope-intercept equation. Okay, so here's our four equations. Y equals 9x plus 4, y equals negative 3/4 x plus 6, y equals 10x, y equals 7. One thing I'd like you to notice right off the bat is that all four of these equations are in the form y equals. They are solved for y. Oh, I kind of ran into my workspace there. Okay, so let's start with what we know about our intercepts and finding the two strategic points. We're going to leave the whole finding 5 points table in the dust. We're going to move right on to our method of intercepts here. So we'll go ahead and put a little tiny table, cute little table for x and y, and we're going to let x equal 0, plug that in. We're going to let y equal 0, plug that in, and find our coordinates of our points. We're also going to take the book's advice and do a third point for checking, and I'll show you why we're going to do this a little bit later here. So this is from 4.2, using intercepts to graph the line. And when you plug in 0 for x, you get 9 times 0 is 0. 0 plus 4 is 4. And so what you get is the number 4. And if you need to write this out, you can. I'm just doing this in my head here. But 9 times 0 plus 4 is 4. Okay, well, maybe I'll write it out. I think I have enough space. Okay. And then if you put in 0 for y, now you've got, now you're putting in 0 for y, so you've got 0 is equal to 9x plus 4. Now you're trying to solve for x, so you would subtract 4 from both sides. You get negative 4 is equal to 9x, divide by 9, x is equal to negative 4/9. So we've got our two intercepts, 0, 4, negative 4/9 over 0. And that fraction, we've discovered one of the situations with intercepts is sometimes we've got fractions that makes it a little difficult to graph. We're going to give it our best guess here, but it makes it a little awkward. So that's why we're going to take the book's advice here and do a third point just to make sure and just to check. I'm going to pick the, let's go negative 1 here as a third point to try. Actually, I'll use purple for that. And when I put in negative 1 for x, I get 9 times negative 1 is negative 9, plus the 4 is going to be a negative 5. So negative 9 plus 4 is going to be negative 5. So there's my 3 points that I can graph. So I've got 0, 4 as my y-intercept. I've got negative 4/9 0 as my x-intercept. And so I'm a little unsure exactly where to put that. It's not quite at half, and that's going to be hard to estimate here. So I'm going to go ahead and graph my third point just to make sure. -1, -5. So -1, -5. 1, 2, 3, 4, 5. Okay, so here's my -1, -5. Here's my 0, 4. And now I'm going to connect those. And that helps me pinpoint where that x-intercept actually is. It's that point, -4/9, 0. Okay? So just a review for graphing here. Let's go ahead and try the next one. Again, I'm just going to use my two points of using the intercepts, plugging in 0 for x, 0 for y. I'll go ahead and do a third point to check. Okay. And let's fill this in here. If we put in 0 times -3/4, that cancels out. We're just left with 6. This really is usually the easiest one to plug in when it's solved for y, because the x piece falls away. You're just left with what's left over. When you plug in 0 for y, it requires a little bit more solving here. So I've got y equals -3/4 x plus 6. If I put in 0 for y and then try to solve this, I subtract 6 from both sides. I get -6 is equal to -3/4 x. Multiply both sides by 4. -24 equals -3x. Divide both sides by -3. I get +8 is equal to x. So I finally got my answer of +8. And then just to check here, I could go one more. Well, it's because it's a fraction, I'm going to strategically pick here a 4 would be good to multiply. In fact, maybe I'll do should I do a -4? No, I like 4. That'll work. So I put in 4, and -3/4 times 4, the 4's cancel, and I'm left with -3 plus 6. That gives you just a +3. So if you need to see that worked out, right here I've got y equals -3/4 times x plus 6. When I put 4 in, the 4's cancel, and I've got -3 plus 6, so y is going to be equal to +3. Okay, so those are my 3 points: 0, 6, 8, 0, and 4, 3. And these are nice numbers for the intercept, so I could be able to get a real accurate line just from those 2 points here. Let's get our axes a little bit clearer. Okay, so I've got 0, 6 as my first point. I've got 8, 0 as my next point. 3, 6, 7. Oh, I'm a little off the grid there at 8, 0. There's my 2 intercepts. So that third point is coming in handy again, just to make sure I'm right on the line here. 4, 3 to the right 4 and up 3. And now I can connect those dots. Okay, so there's my third graph. Let's do this again. Again, we're just reviewing here. So using intercepts, 0 for x, 0 for y, and possibly a third point to check. When we plug in 0 for x, 10 times 0 is just 0. When we plug in 0 for y, you get 0 is equal to 10x. Divide both sides by 10, you get x equals 0 as well. So this is one of those situations where we have both intercepts are at the origin. So we need that third point to check. So far, this one was pretty good, the second one, but so far we've needed this third point every time. So this is not as cute and efficient as we thought it could be, but that's all right, no worries. We're headed to this slope-intercept form, our friend in the graphing business. You have a friend in the diamond business, you have a friend in the graphing business right here with this one. Let's pick a third point. Let's pick, let's see, if we pick too big, it's going to get out of control really quick. So I'm going to go kind of uncharacteristic here and pick -1/2, and that's going to give me a value of -5 when I multiply that by 10, and I'm going to just mirror that with a +1/2, and that one will give me positive 5 as my result. 1/2 times x is 5, negative 1/2 is negative 5. That just gives me plenty of graphing options here. Let's draw in our axes. Here's our x, here's our y, minus and minus, and we've got our 0, 0 is both our x-intercept and our y-intercept, and then we did a couple extras. 1/2 takes us to 5, 1, 2, 3, 4, 5. Negative 1/2 takes us to negative 5, 2, 3, 4, 5. And then we can connect that line. Very steep line here. Okay, we've got a rising positive here. We've got a falling line, goes down as it goes to the right. We've got another very steep rising. Okay, and let's do our final equation here. We've got y equals 7, and hopefully by now there's little bells and whistles going off when you simply see y equals a number or x equals a number. When you see y equals a number, you should start to jump right to, hey, that's a horizontal line, and whatever memory trick you're going to use, the upside down y becomes horizontal. All the y values are this number, which places it across the horizon there, back and forth. However you're going to do that. And when you see x is equal to a number, think of that little v that's sitting there on top of the x, and that stands for vertical. So we get a vertical line here. So in this case, we've got a horizontal at y equals 7. So if you can remember that those are horizontal and vertical lines, you're saving a whole bunch of time. We've got at y equals 7, 1, 2, 3, 4, 5, 6, 7. Oh, it's right up here at the top. If you don't remember, you can just build the table like you would before. Put in 0 for x, 0 for y. Gosh, we've needed it so far, so let's go ahead and pick a third point here. We'll pick 2. And there is no x to put in here. It's as if it were y equals 0x plus 7. You put the 0 in for x, it gets multiplied by 0, it falls out, which it already fell out from the get-go, and you're left with just the 7, the piece that's left over. When you put in 0 for y, you get a false statement. In other words, you can't put anything in for y except for 7. So this one doesn't exist. It does not work. There is no point to doing anything except 7 in the y value. So that's the case here. Again, there's nothing you can do except multiply that value by 0. There's no other y you're going to get except for 7. The equation says it right off the bat. Hey, everything you do here, y equals 7. All your points, they're going to have a coordinate of 7. So here's your 2, 7. Here's your 0, 7. You could plug in anything you wanted here. We've got like negative, let's go like negative 3.5, 7, all of these points along this line. It's going to create a vertical. Okay, so that's just a little review of the graphing, but keep that in mind. I'm going to slide the video down now here for the, well, actually we're going to look at the bottom of the page in the next video, but keep in mind what we just covered because it's critical to how we're going to connect to this friend version of the equation, as I call it. Okay, we'll see you in just a moment.